Hello, everyone. So we're going to wait a minute or two just to give some of the viewers the opportunity to fully connect onto the Zoom. We want to once again thank you for being here today. We hope you can learn a lot about the situation that's going on in Coral Beach and here in Roatan during this webinar. So just let's wait a minute. So hello everyone, welcome to our webinar called Bleaching, How is it affecting Rottens Reef under the framework of our project Reef Keepers Driving Restoration. And well, why should we care about coral bleaching or about our coral reef in general? These corals are essential to the health of our oceans. They provide home and food to a countless numbers of fish and marine species, and they also protect our coastlines from erosions and storms. We would also like to remind you that you can leave your questions or comments in the Q&A section at the bottom of the screen, and we will be addressing them at the end of our webinar. So, our speaker for today is part of the R&B team. She studied at the National Autonomous University of Honduras, UNA, in Tegucigalpa, where she obtained a bachelor's degree in biology. Her interest in marine ecosystems took her to the island of Utila, where she became a professional diver and worked in the conservation of coral reef. Her passion for underwater only grew over the time, and this year we have been fortunate to have her join our team. And now she coordinates the essential part of coral restoration program. And now, without further ado, I present or I leave with you Michelle Serrato.
Thank you for the introduction, Indira, and thanks to all of you for joining us today. We've been very happy with the massive interest this topic has had in our social media. So very thankful for everyone that has made the time to join us today. And without further ado, we're gonna get started. For this presentation, we're gonna be talking mostly about what coral bleaching is, just basic biology and what a coral is and how bleaching happens. And then we're gonna move to a second section of the webinar where I'm gonna be sharing different observations we've made here in Roatan and pretty much having a better idea of how coral bleaching has been affecting our island. So to begin with, we're going to talk about what is a coral. Usually people have a mistaken idea of what a coral is because they don't look like your typical image of what an animal is. Some people can think they're plants or that they're rocks, for example. But in reality, corals are animals. So this is very, very essential to begin to understand them a little bit more. Even though they have a very interesting or unique look to them, they're still animals. And they're very, very interesting and very important for coral reefs. So corals are animals that are composed of small organisms known as polyps. Polyps are very, very similar to anemones or jellyfish, for example. And a cluster of coral polyps is what we call a colony. And a colony, a cluster of colonies is what we call a reef. So in this picture, for example, you can see a bunch of like tiny circles. That's what we will call a polyp. And that makes a little bit more sense when we look at their anatomy like this. So we can think of polyps as, for example, jellyfish upside down. And pretty much all of them look like this. So when you're seeing a coral colony, like this. You're seeing a bunch of polyps or tiny animals that look like this. They have different parts to them. They have a mouth, they have tentacles that they can move. That's one of the misconceptions about corals as well, that they don't really move, and therefore some people think they're rocks, but they have tentacles that even though they're tiny, they can move and that they can use to feed themselves as well. All of those polyps are connected with different tissues, so they all communicate and act as the same colony or as the same organism. They also have nematocysts, which is stinging cells that you can see in their tentacles. And something very unique and important about corals is that they have algae within their tentacles, within their tissue. This algae is called zooxanthellae, and it's very, very important because it's going to take us to our second point when it comes to coral biology. So we know that corals are animals, and now we need to understand how they feed so we can understand why this algae, zooxanthellae, is so important to this animal. The way that corals feed, as I mentioned before, they can use their tiny tentacles to grab food or particles in the water, and they use them as arms, and whatever they grab with their tentacles, they're putting into their mouths. But most of their feeding comes from algae, zooxanthellae more specifically. They have a symbiotic relationship with this algae. This means that the zooxanthellae provides a benefit to the coral, and the coral is also providing a benefit to the algae. This algae is housed within the core tissue and is the source of the at least 70 to 80% of the food and nutrients and energy that this coral is going to be receiving. And they do this through photosynthesis. This zooxanthellae also gives corals their color. So whenever we see different colorations or very vibrant corals, that's the zooxanthellae that gives them that color. Zooxanthellae, for example, is also found in different organisms like nudibranchs, for example, and they make them very colorful as well. But basically, this tiny algae that's living within the coral tissue is extremely important for the coral because that's their main source of food, especially in the Caribbean or areas that have very shallow reefs. Most of their energy comes from the photosynthesis that the algae is doing. So this is very, very essential to understanding corals pretty much. And this is gonna be a huge factor when we talk more in depth about coral bleaching. So for now, it's just important to keep in mind that corals are, one, animals, and two, they have a relationship with algae that they really, really need in order to feed themselves. Besides algae, corals need a lot of different conditions to thrive in reefs. A couple of them, for example, are warm temperatures, so anything between 18 to 35 Celsius degrees. They also need certain depths. Most coral reefs are within shallow waters, so depths from 10 to 27 meters. That's the range where we can find most coral reefs. They also need a good water quality. They need enough oxygen, and they need the presence of different herbivorous species. So besides their algae, they need a lot of other conditions that are necessary for their health and just necessary for this balance to be maintained within nature. However, we're in an ever-changing world, and nowadays coral reefs are facing many, many different threats. And just to name a few, we have overfishing, pollution, climate change, unsustainable tourism, ocean acidification, deforestation of mangroves and seagrass beds, and there's many, many other threats that are currently threatening our natural resources. And this is just to briefly mention a couple of them. We're not gonna go into detail into all of them, but we're gonna talk a little bit more about climate change. So we're going to be talking a little bit more about climate change, and this is because it's very, very linked to coral bleaching. Coral bleaching can happen due to different threats or stressors, but usually it's more heavily linked to climate change or rises in temperature. So when we're talking about climate change, we're referring to the change in different conditions like temperature or rainfall, for example, and how these conditions are changing over long periods of time. And nowadays, what we're seeing is that the trend is that we're seeing more extreme conditions. So, for example, here in the Bay Islands, maybe 10 or 20 years ago, rainfall used to be a lot more heavy. I've been speaking to people that have been living on the Bay Islands for years and years, and they always tell me how for the rainy season, rain was extremely constant. They will have rain for 2 months straight, and they will have more and more rain, and also the temperature is a lot lower. However, nowadays what we're seeing is that our rainy season is very different. Our rainy season is a lot warmer. We're not seeing as much rainfall. It might rain for a couple of days, but we're not seeing continuous rain. So that's just an example on what climate change is and how we're seeing it. And again, the trend is that most of these conditions are getting worse or more extreme. That's also a very huge threat to our communities. Because of the way Honduras is positioned in our social context as well, we're one of the places where we're going to be the most vulnerable, and we're already the part of the communities that are very, very vulnerable to climate change because we just don't have the means to adapt so quickly. It's been reported that over the last century, global ocean temperatures have increased by 1 Celsius degrees. And this might not seem like a lot, but it's incredibly, it can change and it can affect many, many things like we're going to see in a little bit. The first global bleaching event that was ever caused about 16% mortality of corals worldwide in 1998. And for example, Honduras has suffered their worst coral bleaching event in 2017. So that was not very long ago. We will still need to assess how this current bleaching event can compare to that one. But something very interesting about climate change as well is that it has increased the frequency and severity of our bleaching events. And you can see that very easily with this data. Just to think that in 2017, we had a very bad bleaching event, and now 2023, we're seeing another bleaching event. They're becoming more and more frequent and more intense, not only in leaving the reef just extremely vulnerable, but those species that maybe survived a couple of years ago might not have been able to adapt currently. So now talking a little bit more about what coral bleaching is. Coral bleaching is essentially the breakdown of communication between corals and their algae. So we spoke about algae a lot already. We know why they're so important. And during a coral bleaching event, what happens is that corals are so stressed that they expose this algae that's within their tissues. Coral bleaching can happen because of many different threats. It can happen because of sedimentation, pollution, for example, but usually it's more linked to a rise in temperatures. And that's what we have been seeing here in Roatan, at least. So again, the coral is just so stressed that their first response is to expose this algae. And if the conditions don't get any better, meaning if the temperatures don't go down, for example, the coral is going to remain without this suitable belly. So what we see when we see bleached coral is we're pretty much seeing like a transparent tissue. We're seeing their skeleton, which is white, and we're not seeing any of that beautiful color that the algae is given to the coral. Also because they're losing their main source of food, they can literally starve to death because they don't have that energy that the algae is providing to them. So pretty much coral bleaching is a breakdown of communication between corals and their algae. That's very, very essential to them. Something important to keep in mind is that coral bleaching or a coral that is bleached doesn't necessarily mean that this coral is now dead. That coral is still alive. And if the conditions get better for them, they can eventually recover. So bleached coral does not equal a dead coral. Here in this picture, we can see different stages of coral bleaching. Here at the Roatan Marine Park, for coral nursery specifically, we give them a value of 5 or a scale of 5 when it comes to coral bleaching, as you can see on this image. So for example, a value of number 1 will be a coral that's completely healthy. It doesn't have any signs of bleaching. It's just full of color, as you can see in here. Number 2 will be a coral that's partially bleaching. It has a couple of areas that are more pale than others. For example, in this picture, you can see staghorn coral, and it has on the tips, it's like very, very pale. Number 3 will be a coral that's slightly pale. So you can see the difference in coloration between all of these pictures. Number 4 will be a coral that's pale. They have lost most of their color out around its tissue. And a number 5 will be a coral that's completely bleached. So at this point, the coral looks almost like a bone. You can see its whole skeleton and it's completely white. However, let's remember that this coral is still alive. So now we're going to move into talking a little bit more about the current state of Roatan's reef. So for this part, we're going to be sharing a couple of different observations we made along the island. We're going to be sharing about monitoring dives we did in 4 different dive sites between West Bay and Sandy Bay. This was at the end of October, in October 25 to be more exact. This was considered the peak month for coral bleaching in the Mesoamerican reef. So it was very important for us to assess bleaching during the time. And the dive sites that we monitor were Mandy's Eel Garden, Dar Stream, Diane Stream, and Overhead Reef. We're also going to be sharing a couple of pictures from a monitoring dive we did at Cordelia Banks. In Cordelia, we monitor 4 different points, and we did this in November 29th. And for last, we're going to be sharing a couple of observations we have made in our coral nursery. And this is going to be for the months of October and November. And we're just going to be sharing how we have seen or what we have seen when it comes to bleaching in our coral nursery, which is more of a control area. And also to say a huge thank you to all of our partners and collaborators. It wouldn't have been possible to make all of these different monitoring efforts without any of them. So big shout out to Healthy Reefs for Healthy People, Adventure Scientists, CERNA, Marina Mercante, ICF, Bay Islands Conservation Association, and Island Coral Atlas. All of them have helped us tremendously to continue doing this work. So thank you so much to all of them. And just to highlight how collaboration is extremely important when it comes to conservation work. So what I'm going to be sharing here is a couple of pictures that we took during some transects. All of these pictures were taken randomly, and this is because when you want to survey an area in order to have a more realistic or accurate representation of what's happening in there, you want to do this in a random manner. So this is what those first pictures are. All of those pictures have not been edited at all as well, and most of them are taken from 1 meter distance from where the diver is taking the picture to the reef. So this is what we're going to be seeing for this first section of the presentation. So in this picture here, this one was taken in overheat reef. You can see how very obvious the coral bleaching is within this area. Is just so notorious and it's so vibrant. It's almost making the picture overexposed. And it's just so easy to tell that coral bleaching is happening in this picture. Pretty much all of the species that you can see here are completely white. And in here, just to point out at a few of those species, we can see three different stony coral species that have been affected by bleaching. We have our lobestar corals or Orbicella species. So this one's over here, the ones that look like fist. These corals are very, very common in the shallow areas as well. So if you're an avid scuba diver, I'm sure you have seen them at some point. But you can see this one over here, and there's a smaller one around this area as well, and they're completely white. We also have a finger coral over here, Porites species, and same thing again, you can see how it's almost bone white. We also have a very big brain coral species over here, Colpophilia, and you can see the same thing again. So this picture is very interesting because within that small area, we can see how many different species have been heavily affected by coral bleaching. And again, it's just very, very obvious how bleaching is happening for this species. Sadly, the bleaching has been very tragic, I will say, here on the island, that even without getting into water, you can still see that it's happening. It's almost like it's glowing and it's just so in your face, pretty much, which is very, very sad. So for those corals, it's very, very obvious that bleaching is happening, but coral bleaching can look many different ways as well. So I have this other picture. This was taken in Mandy's Eel Garden. And in this picture, for example, if you don't really know much about what this coral species would look like normally when they're healthy, you might think they're not stressed at the moment or that nothing is wrong with them because we can still see some color. But for example, we have two mustard heel coral species over here. There's one here and another one here. And even though you can still see a little bit of color, this species, when it's healthy, it usually looks a lot more like this. So very much like a mustard color, like the common name says. So once you see those two pictures side by side, it's then very obvious that there's something wrong with this other coral over here. That's also a Porites species. Now, on the other side, we have this massive starlit coral. And this coral is very, very big, and you can still see a little bit of color, but when they're healthy, they're more of a brown color. And something very interesting about this species and specific is that when they're stressed or bleach, sometimes what they do is that they will look a very vibrant color, and it could be like a pink color or a blue color. So in this picture, for example, you can see the same species that has a very purple tone to it. And if you see this without knowing which species it is, for example, you might think that's a very colorful and healthy coral, but that's not the case. It's just that different species react differently. And this one specifically, what they do is that they turn that color to protect themselves from the UV rays from the sun. So that's very interesting, and it's just to show you how different species can react differently when it comes to different stressors. For this massive starlight coral, there's also something very interesting happening here because this coral is suffering from two different stress factors in here. One it's very, very pale, and two, it has a disease. So all of these dark spots that you can see, they're like red coloration, and they're forming different circles around the coral. That's a disease, and it's actually called dark spot disease. So it's very, very sad that we're seeing that this coral is, suffering from a disease and coral bleaching. So this picture here is mostly to show how different species can react differently or look very differently. So not all coral bleaching has to look uh, extremely white, or it doesn't have to get to that point for us to know that there's something wrong happening for these animals. In this next picture, this one was taken at Dar Stream. We can still see a couple of different species that have been affected. So to name a couple of them, we have our Sahorn coral, or Acropoda cervicornis. You can still see that this species has a little bit more color with that. It looks a little bit more orange, but still very much pale. And especially on the tips, you can see how it's been affected by coral bleaching. And something interesting on this picture as well is that we're seeing species that we don't usually see affected on the reef by things like diseases or other things. Okay. So how I was saying before, in this picture, there's something very interesting happening as well. We're seeing a couple of species that are usually very resilient in reefs being affected by coral bleaching. So in here, we have actually two different species of fire coral, which is this one over here, and you can see it over here as well. And fire coral is a very opportunistic species, is a coral species that pretty much grows everywhere and anywhere at any given time. And we also consider it to be a species that's a little bit more aggressive because it overgrows everything, and it competes for space, and it can also compete with other reef building coral species. So usually we consider fire coral to be a very resilient and just a strong species overall. We see it everywhere. Usually if you go and swim at a dock or something, you might see that the wood pillars are going to be covered in fire coral because they just grow very fast and they're very quick to colonize areas. So usually it's a very strong species overall, and it doesn't really, or we haven't seen it being affected by coral diseases, for example, or it's not affected by hurricanes as much. They recover very quickly. So it was very interesting to see this species being affected by coral bleaching, and they were completely white. I'm sure you cannot appreciate them fully on this picture because, again, these were random pictures. But we saw a lot of big fire coral colonies that were completely white. Something interesting we saw as well was that we saw a lot of different soft coral species bleach as well. And soft corals in the last couple of years have had a tendency to not be decreasing as much. More recently in the Caribbean, we've been having a lot of issues with coral diseases, but most of these coral diseases are happening to stony coral species. So we're not seeing soft corals getting sick often. For example, they do get sick and they can get sick, but it's just not something that we see so often here in the Caribbean. And it's very, very interesting to see this type of species being affected by coral bleaching as well, because it's just not something that we have been seeing. There's even some dive sites around the Bay Islands where, for example, most of the stony coral species have died, and the soft coral species have taken over because they're just doing so well. So it's definitely very interesting and sad as well to see that the species have been affected as well. And for the last dive site that we monitor, we have Diane Stream. And in this one, you can see in the whole picture pretty much one single species of coral, which is lettuce coral or Agaricea dunifolia. And you can see how this species is completely white as well. It's very, very obvious that it's stress and that is bleach. And this is also a species that we haven't seen being affected or decreasing in the last couple of years. It hadn't been affected by stony coral tissue loss disease, for example, and they used to thrive, especially within shallow areas. We will see very big patches or a lot of coral coverage that was this species in a specific. So it was very interesting to see it being so affected by this coral bleaching event. Now, moving on to the monitoring we did at Cordelia Banks. So if you're from the Bay Islands, I'm sure you have heard about this site before. Cordelia Banks is a very, very important site for us in Roatan because it's a site of importance for wildlife. It's believed to be one of the only few sites or areas in the Mesoamerican reef that still have a very high coral coverage of Acroborda species. So staghorn coral, for example, the one that you can see on the picture, this is a coral that we don't see as much or in the amounts we used to do many decades ago. So Cordelia Banks is one of the very few areas that still have a lot of coral coverage of this species, and that makes it a very, very important area for the whole Mesoamerican reef. This area pretty much can feed the rest of the Mesoamerican reef when it comes to biodiversity and genes for this one species. So Cordelia Banks is very, very important for us and is pretty much an emblematic site here in Roatan. So along with different collaborators, we joined efforts and we went to monitor this area. And I'm just going to be sharing a couple of those pictures we took during the dives. And what you can see in here is very big patches of staghorn coral and also lettuce coral. So for the staghorn coral, you can see that most of them still remain healthy. They have recovered from coral bleaching. You can see that the tips mostly of the corals have tissue in them. They still look very colorful. They look that very brown, orange coloration that they usually have. But we can also see a lot of algae that has been growing on top of the corals that have died. And on this picture as well, you can see a lot of bleaching still happening for the lettuce coral species. And you can see it, how it glows pretty much in the picture. So something very similar is happening on this picture. On this one right here, you can see a very big patch of lettuce coral, but in here you can see a lot of mortality. So we know that a coral it's dead pretty much when we see algae growing on top of it. Once the algae starts growing on top of their tissue, that means that coral is dead, is completely gone, and doesn't really have a chance to recover at this point. So in this picture, you can see a lot of that. Pretty much all of the areas that are dark, that's algae that has been growing in there. So you can see a lot of that. And you can also see a lot of active bleaching happening. You can see all of these white areas that are completely bleached. And you can see a little bit of like mortality or a transition in mortality. So areas that have been dead very recently and algae is just starting to grow on top of them. And on this other picture, you can see, for example, how this soft coral is completely full of color. It doesn't seem affected at all. But you can see, for example, in here, there's a remain of a brain coral, and you can see how that one's still completely white. Uh, I also have a video of Cordelia bugs, and this is pretty much what it looked like. So in this video, very similar to the other pictures, what you can see is how the Saharan coral is doing a little bit better and how the lettuce coral is still very bleached, and you can still see a lot of mortality happening. You can see a lot of algae growing in this area. And overall, that's what we saw the most at Cordelia banks. That's what our preliminary conclusions can be. So now to finish off the presentation, we're going to be talking about different observations we made in our current nursery. So currently, Roatan Marine Park has the biggest coral restoration program in Honduras. We have about 40 coral trees where we propagate staghorn and a few staghorn coral. And when I say that this is a controlled environment, I mean that we're constantly seeing the same individuals, we're seeing the same colonies over and over again. So it gives us a better idea of what's going on when it comes to stressors like coral bleaching and how the same colonies are reacting to it. So this is what our coral nursery should look like most of the time when conditions are favorable and when everything is in balance, and when the corals are thriving as well. But this is what we were encountering within the last couple of months. So you can see a very big difference and how this tree is pretty much completely white. Something that we saw within our core nursery as well is that even though the same species can be within the same conditions, they can react differently to different stressors. So here's a very good example. You can see this three different fragments. They're all of them have different genes. They're all different genotypes, and all of these fragments are in the same depth. They're receiving the same amount of lighting. They're receiving the same amount of sedimentation. They're receiving the same sorts of stress, but they're all reacting very differently to them. So in here, you can see how this fragment is looking pretty much healthy. It still has a lot of color to it. Maybe the tips a little bit pale or white, but overall it's doing pretty well. This fragment in the middle, you can see it's a lot more pale. You can still see a little bit of coloration, mostly towards the base, but you can tell that it's stress and that something is happening to it. And this last fragment over here is completely white. So these are just different ways that different genes and genotypes can react to the same stressors. And when we talk about genotypes, I think a good way to understand that or to compare it to will be humans. For example, all of us react differently to different things. I, for example, met some people that never get sick, they can never catch flu, or if they do, it only lasts like a day for them. And I personally am someone that if I catch a cold, I'm gonna be sick for a month and I'm gonna be struggling. So that same concept applies to most animals, and corals are not different. And you can see it very, very clearly on this picture. And it's something that we saw a lot within our coral nursery. So when it comes to numbers and data for the month of October, none of our coral nurseries were healthy. None of them had no signs of stress or no signs of bleaching, and 100% of them were either pale or completely bleached. Just to keep in mind that this number is for all different um, signs of stress. So in here we include corals that are completely white, completely bleached, and we also include corals that are pale. So there's different things happening in this number, but overall for October, 100% of our corals in our nursery were affected and stressed to different levels. However, something interesting that we saw is that we didn't see a lot of mortality within our coral nursery. So even though that for October, all of them were very, very stressed, most of them weren't dead or dying. We only saw about 0.68% mortality. So that's a very, very low number, and that is very encouraging because, again, even though all of these corals are bleached, they're still alive and they still have the chance of recovering. So thankfully for the month of November, that's what we saw. We saw that now our number of healthy coral trees increased tremendously. So for November, about 40% of our coral trees were healthy. This means that they had zero signs of bleaching or paleness. So that's a very big number of corals that recover very, very quickly. And I think it was definitely due to the constant storms that we had in Roatan for that month. I think it was raining nonstop for like a week, and that really helped cool down the temperatures and just make it a more stable environment for the corals. So that really, really helped us a lot, and that made a huge increase in the health of our corals. And for November, again, you can see that the number of pale and bleach corals went down to 60% of and for the mortality, it did increase a little bit. So by November, we saw almost 4% mortality, but this is still a very low number when it comes to the actual amount of corals that we have in the coral nursery. So we were very happy that we didn't see a lot of mortality. We didn't have to see a lot of corals dying, and we saw that most of them were able to recover. And I don't have any data for December just yet, but overall the conditions are looking a little bit better, and most of our corals in the nursery are thriving. Though this is different for many species, but for the staghorn coral specifically and the fused staghorn, they were doing a lot better. So those are all of the observations I had that we have been doing here in Roatan. So some of the conclusions that we can make out of this is that the high temperatures that were about 31 Celsius degrees for a couple of months have affected the coral reef in the island of Roatan, causing coral bleaching for most of the areas of the reef. I know that I only show a couple of different areas and sites that we monitor, but the coral bleaching was very much present, and I will dare to say the whole island. Most of the areas look very similar one to another, and there was no a very notorious difference of how bleaching was affecting the area. It's not like we saw coral bleaching in the north of the island, but we didn't see it in the south. It was pretty much everywhere. Uh, One of the other conclusions that we can make is that coral bleaching has affected multiple species of both stony and soft coral species. Another conclusion that we can make is that even though the temperature has gone down, I think currently it's about 29 degrees Celsius. Some species have recovered thanks to this, but most of them are still either pale or bleach. And mortality can already be seen in some species as well, especially the lettuce coral, as I mentioned before. So for our next steps, we need to follow up on our monitoring activities and the areas that we survey to assess and have a better idea of how this event has affected our reef. We need to continue making observations on the survival of our colonies and the coral nursery and try to identify those genotypes that are more resilient to warmer temperatures and bleaching. And we also need to analyze the conditions and an appropriate time to start our coral outplanting activities again, because this is something that has affected us tremendously. We cannot continue to plant coral onto the reef because the corals have already been suffering a lot of stress and we cannot put more stress into them. Some of the ways that we can help is just being a conscious either a visitor or a tourist or just an individual. All of our actions matter, even if they're very small. So definitely, if you're interested in visiting Roatan or you live here and you want to share these tips or tips with different people, just try to be more mindful when it comes to our all of our biodiversity. Don't touch our wildlife, don't harass them, don't chase them, don't take anything from the ocean. Try to wear reef safe sunscreen. Don't purchase any what's the word, artisanal products made out of organisms. Don't take shells with you home. Put the trash on its bin, try to reuse, recycle as much as possible, and definitely try to share this type of knowledge when people are entering this area. Let's just be mindful that we're in a marine protected area and we need to treat it as such. And now we're gonna have space for different questions and just to thank all of you for joining us today and for bearing with my English.
And you were totally amazing, Michelle. Thank you for sharing all that valuable information and insight with all our viewers. So now we're going to go on to the Q&A section. You guys have been really active in the section, so I'm just going to start off by reading some of the questions, and Michelle is going to start answering them. So the first one we have is from Tori Lee. She says, "Have you noticed any trade-off with the coral genotypes that are more tolerant to heat? For example, do they grow slower?
Do they what?
Do they grow slower?"
We have identified a couple of um, we have
We have
identified a
identified.
couple of genotypes that seem to be more resilient than others. So far, we cannot assess if they grow slower, but even if a genotype or a specific coral can survive a bleaching event, that doesn't mean that it's gonna survive a future bleaching event. That definitely still impacts their health. It makes them weaker in the long run, that it affects their growth rate, their ability to reproduce as well. So it's very tricky because even though they might seem very resilient or strong currently, we don't know how they might respond in the future. And events like this one are still going to impact their health.
Okay, thank you, Michelle. We have another question from Butch Henderson. He's asking if do any bleach resistant corals live in the ocean around Roatan?
So all coral species can be affected or impacted by coral bleaching. We don't have a species and a specific that's immune to it. All of them um, can be impacted or affected by it, just to different levels. But we don't really have one species that we can say that this species is immune to coral bleaching. I think that will be the best scenario, but sadly, it's not the reality. Is pretty much like a underwater pandemic, and everyone is affected in one way or another.
And we have a question from Angel Gonzalez from Panama. He's commenting that he lives in Bocas del Toro, where is a region that is very similar with the Bay Islands, of Torre Islands. And he's asking us about the recording of the webinar. So this webinar is being transmitted live on Facebook Live, so you can rewatch it there. Or we also upload the recording of the webinar to our YouTube channel. So if you can either watch it on our Facebook account or on our YouTube account. Thank you for your question, Angel. Okay, we have another question from Jorge, who is asking, do temperatures need to go lower?
I think currently the temperatures have gone lower. I think that a normal temperature here in Roatan will be about 28 to 29 degrees. But once it starts to hit 30, 31, we start to get a couple of issues. But something between 28 to 29 is more of a normal range for us. They have definitely gone down a lot. I think some areas are about 28 degrees right now. So they have improved a lot, which is very, very good.
Perfect. We have another question from Kirsta. She's asking if we can comment or discuss any the impact of SCTD on in Rotterdam's current reef.
Yes. So sadly, we have been affected very, very tremendously by stony coral tissue loss disease. I believe that Roatan Marine Park has put out there two research papers about this. I think they're in Frontiers. So if you can Google Roatan Marine Park, stony coral tissue loss disease, you will be able to access to those two documents. But we have been impacted by it a lot. Similar to everywhere else in the Caribbean, we have lost many, many species due to the disease. And now to help the situation, we're trying to expand our efforts with coral restoration, and we're moving towards sexual assisted reproduction. And that's also what our campaign Reef Keepers is all about, is to trying to share that knowledge with different stakeholders in the country, and try to upscale those coral restoration efforts, because we've been impacted so tremendously by coral diseases in the last couple of years.
And next we have a comment from Rick Carter. He's telling us that he would suggest that we add both water temperature and the speed of the flow of current during each month to gather more data points. And he can also he's offering to help us analyze that data and pinpoints using AI, so artificial intelligence, and relating the data to Scripps Institute of Oceanography. So thank you, Rick. If you can send us your information, your contact information, so we can speak after the webinar, that would be amazing. Thank you for your support. And we have another line of positive comments from James, Cara, and Dan. Thank you so much for all your positive feedback. And we have another question from Walter James. Is the trend over the past 5 to 10 years looking good or bad?
I think it's definitely very hard to say. I think everyone that's within marine sciences just wants to stay optimistic. Um, I think that the reality is that climate change and other stressors have just increased and gotten worse. But I don't think we can give up, and we definitely need to remain positive and try to uh, put more efforts into everything we can.
Thank you, Michael, for that possible positive outlook. So we have another question from Janet Torres. She's asking if during your service have you noticed a difference between the water quality from each site that can increase or decrease the growth of the corals?
We haven't been looking that much into water quality. It's definitely a challenge when it comes to assessing coral restoration efforts. For example, this year we have been impacted a lot by coral bleaching. So the corals that we have outplanted before are affected by coral bleaching, and they have maybe even died from it. So it's always very hard, and it's always a challenge to assess correctly what's going on in the underwater world. But we cannot, discard different things, and everything always plays a huge role into coral health.
Thank you. And we have a question from Ana Maria Arenas. She's asking, with so many corals in the ocean gardens facing bleaching and dying because of rising ocean temperatures, do you think it's worthwhile to keep investing in coral restoration in the ocean?
I think it's definitely worth it. I think Honduras, for example, has so many beautiful and rich natural resources, and we can only try our best to protect them. There's definitely a need to upscale those efforts and to try to incorporate land-based solutions as well, which is something that we're looking into. And it's something that other coral restoration practitioners have been developing as well. So, for example, in Florida, they had the same bleaching event, but because they had the means and facilities to rescue their corals, what they did is that they took them outside of the water and put them in land-based facilities to keep them alive. So that's something that we definitely are looking into and need to look into in order to try to do our best to protect our resources.
Okay. We have another question from Jorge. He's asking how long is the cool season in the water here on the island of Roatan?
So rainy season here in Roatan is about from September to February. But I think it gets very, very rainy around November. So that's our rainy season. Here in Roatan is only dry and rainy season, but it's not really necessarily cold.
La otra persona.
All right. Thank you so much, everyone, for joining us today. We highly appreciate the support. If you want to help us directly, I'm going to leave on the screen different QR codes that you can scan. If you would like to make a donation to Rotan Marine Park, all of those donations go directly towards our conservation projects. And we say that there is never small donations, all of them serve a purpose, and we're very, very thankful for them. Also, if you want to visit our eco store in West End, here's a code for it as well. And if you're interested in volunteering with us, there's also a QR code for it as well. And I'm going to be leaving my email at the end of the presentation as well if you have more specific questions or if you would like to get in touch with us and our research programs. But other than that, thank you so much to everyone for joining us and for supporting us. And hopefully we'll see you all again with better or more positive news as well.
Thank you so much for watching us, and until next time.